Hello everyone. Before we proceed on, I would like to thank Astronomer for sponsoring our today's video. So if you're diving into the world of data, Astronomer's product Astro makes it super easy to orchestrate workflows and manage complex data systems more efficiently at enterprise level. So whether you're a data engineer or someone who's more passionate about data, so you should definitely check out Astros and its features to see like how they can help in transforming your organization's data journey more efficiently. So I would also provide the link in the descriptions so you can explore around Astronomer and its products on your own. Thank you.
Hello, Sanyam. So this is Padma Priya. I work as senior data engineer, and maybe we'll start with your introduction, your projects, and tools you work with. Maybe.
Okay. Yeah. Hi, Padma. I am Sayam. I am working as a data engineer for last 3 years. I worked on building many end-to-end ETL pipelines and a generic framework that we can use for creating data lakes, data mart or warehouses, and also on the real-time data lake using Kafka, Spark, vector streaming, Ethereum. Uh, with the technology that I have mainly worked on is Spark using Python, then Hoodie, Kafka, Devarium.
Okay. Can you maybe talk to me about like your recent project or a problem statement, if you could share, like maybe just a glance at it.
Yeah, sure. So on as I was saying, like I'm working on building a generic framework, like right. So in that we used to build different features that on the top of that framework, right? So I have worked on ingestion framework where we right before that what we used to do is do the full load and the CDC using the DMS service of the AWS, which is like for historical is very costly. So in place of that, I have developed an ingestion framework where we can load the historical data using Spark from various sources like RDBMS, NoSQL, and somewhat like Snowflake. So all this type of sources we can
Mm-hmm.
may pull the data and then store that in the transient zone, or maybe we can say the bronze layer. And on top of that, we can run our framework to for the silver and the gold layer, like treasure and the refined.
Okay, so you mentioned like different layers of storage, right? So can you explain more about it in detail? Like, where do you use those, and why do you kind of have that segregation, and in which layer? I mean, what kind of data you kind of store?
So in the bronze layer or like transient zone in our case, we store the data in a raw format where we just put the data in the form of file without processing it. And then in the silver layer or the treasure zone, in that we read the data from the transient zone and store that data in the form of tables using Hoodie. So in that we take care of all the inserts, updates and deletes that are taking place on the source tables. And then finally the gold layer or which is a refined zone. In that basically we do all the kind of transformations and maybe joining different tables to create a finally you can say check we basically extract the meaningful data from the table.
Okay. So as I understand, you mostly kind of worked from ingestion to processing in maybe recent or like in your experience, correct?
Right.
So I have a question around Spark basically. So let's say like you have skewed data. You understand a skewed data, I suppose, right?
Right,
So
right.
yeah, how do you optimize a Spark job like to handle that skewed data, and also like just provide me an example scenario like where you might have faced, or maybe in your project, or maybe in your personal practical things and all, where do you have faced that? Give me an example scenario and how did you solve it, and solve that problem with.
Okay, as of now, I haven't faced this problem of skewed data, like with the type of
But
tables.
what? Okay. Mhm. What is skewed
Yeah.
data? What do you understand by it? You might have
So
like at
basically,
least know
yeah.
about it, I guess.
So basically, skewed data is basically when we have more data in one partition and compared to the other partition. Let's say if one of my partition have the 98% of the data and others have rest 2% of data, then it is a skewed data frame. And basically, it will generate a problem like when we are doing let's say any operations on that data frame. So one of my worker node will be fully occupied because it will have the most of the data and rest workers will be like so. Yeah, this is a skewed data problem. So like the solution that I'm aware is like we can maybe like do the repartition of the we can do a repartition of this data so that like the data can be equally divided into each partition. And the other that I've heard of is sorting technique that we can use on the skewed data frame.
Okay. Do you know anything more about what do we do in a salting technique? Any idea?
Yeah, but currently I don't remember exactly.
No problem. No problem. Yeah. Okay. So you might have we'll go to some basics maybe. So can you give me like the difference you understand between an RDD data frame and data set, and why do you use what in which scenarios maybe?
Okay, yeah.
Which of these structures like you most used maybe? Tell me that. Which one of it you mostly use in your?
Yeah, so I have mostly used data set and the data frames, but yeah, so um, RDDs and the data set. So basically, the RDDs are the distributed data sets, and that.
Okay, not a problem. Maybe we'll jump into something different. So I see in your profile like you kind of extensively work with Kafka and streaming as well, structured streaming.
Right.
So
Right.
yeah, yeah. So let's say just explain me in few words like how would you design a real-time data pipeline using both of these tools or like here, and what are the key components or considerations you would see in that so that you maintain the data consistency and handle the failures as well.
Okay, and like the tech stack is Kafka and the Spark, right?
Yes, Kafka and structured streaming. That's what I think you have experience with. So I just want to
Okay,
explain.
so
Explain.
yeah, and just one more thing, and I have to explain how we push data into Kafka as well, or is it like I have to start from?
Just explain me how do you design a real-time pipeline using these two technologies like Kafka and structured streaming, and how do you handle the concepts like consistency, maintaining consistency, and how do you handle the failures? I don't want any like, bigger example. Just take a small example and just explain me how do you design it.
Sure, and just one more thing, and what about the historical data? Like there's some historical data available, or we can just start streaming if there's the
Uh,
incremental data.
just think it's a fresh pipeline. Maybe
Oh,
you just have to start it. Very minimal. Not you don't have too much data to kind of maintain, handle, or load in history. Yeah.
okay, so like in this, what the I'll do is in the Spark streaming and using Spark and Kafka. So basically in Spark we can Spark streaming we can connect to the Kafka like the from the very first data that is available in the Kafka topics. And secondly, while after writing all the Spark logic like transformation and all, while writing it, so we can write it in the form of OD tables to maintain all the inserts, updates, and deletes that are there. And secondly, we can store the checkpoints at some location, maybe like maybe on S3 or some other location, so that in case of any failure, we can restart from that particular point from where my job fails. And secondly, at the Kafka side, I will have some retention period of the messages. By default, it is 7 days, but according to my data load, we can adjust it. Like if it is less, then we can keep it 7, but if it is more, so like in order we don't have to worry about the Kafka storage. We can maybe reduce it to somewhere where around 3 or 4 according to our use case.
Okay. So as you said, right, yeah, you're streaming data and all. Can you explain me the concept of back pressure in streaming and
Yeah,
how do you handle it?
so back pressure is when, let's say, when our throughput in the Kafka is more and our while streaming it, we are streaming less messages, let's say, per second. So it creates a back pressure, right? So in order to solve this, what we can do is we can maybe increase brokers on the Kafka side so that since Spark is a distributed computing, so we can consume more messages and
Okay. And okay. So can you explain me the like concept like or how do you implement the exactly one semantics in Kafka and to have your end data proper?
even
Basically, what is that and how do you implement it?
if I'm not wrong, exactly one semantics is basically we consume one message only once,
Yes.
right? And to ensure that there is one Kafka property, like where we can set this,
Mm-hmm.
but I don't remember that property.
Okay. Okay. So you mentioned you worked with Hoodie, right? Can
Right.
you explain me what is Apache Hoodie and what is the use case? Why did you go for using it, and what are the features you have used it, and why?
Yeah, so basically Apache Hudi is a utility or framework that we can use for basically managing the data in a file system as a table, like where we can do all the operations like insert, update, and delete on that data files and manage that in like as we see our table, or like we can create a like database, something similar to what we see in the maybe RDBS, RDBMS, or like, right. So Hudi has in that. So the use case is basically, since I has mentioned, like we are I worked on AWS cloud, right? So we were storing data on the S3, which is a file storing system. So a file storage system. So in that, since we are storing data in the form of files, we wanted to create a table so that we can query that data easily. We can do all sort of operations there, right? So in that, Hudi is a utility which help us to do that easily. So that's why we have used Hudi. And coming to the features that I've used of Hudi is, so like I've used all kind of feature, like we, since in our table we have all insert, update, and delete, that we have used. The schema evolution is there, that is also I have used in some cases. And yeah, and then so there is on Hoodie side there are two type of tables: copy on write and merge on read. So even I have worked on both of them.
Can you
Yeah.
explain what are those and when do you kind of choose?
Yeah, so basically, copy on write, what does this like? So after writing the data, Hoodie shows the metadata and deletes the older, like we set the commit written, right? So according to that, it deletes the older commits accordingly. So in the copy on write, while writing the data, it performs all of, after writing the data, it performs all this function and syncs the metadata with the Hoodie table. In MOR, it basically creates the logs file and it uh, asynchronously merge that logs with the data files and update the metadata accordingly, and deletes the older commits. And COW is used when we want our reading faster, we want our querying speed faster on the table, and MOR is used in the cases where we want the writing speed to be fast.
Okay. And can you explain me the design? Like you mentioned that you kind of used Hoodie or like let's say the table format in AWS. You created some design around S3 and Glue and all, right? So can you talk to me a little bit about that? Like, are you involved in that piece of work, or I mean, to what extent you're working in that particular piece?
Yeah, like
What is your role
in my
basically in that, so that we can proceed?
yeah, in my like first company, I was totally involved in that piece. So yeah, I know.
Okay, can you explain me the design, like from where the data is coming? What is the source of data? How are you ingesting it into like Hoodie plus S3 kind of a storage, and like how are you creating? I assume you're creating a catalog using Glue, like to store the metadata. How are you doing it, and how are you automating it? Like, are you do? I think definitely it should be a pipeline where it's continuous. So how are you designing it? How did you design that? Can you explain me?
Okay, so if I'm, let's say I talk about the bad jobs. So in that, what the source can be MySQL, Postgres, anything, right? So what happens is we first set up, for the incremental node, we set up a DMS task that ingests the incremental data into the S3, let's say transient zone. And in that, basically how it shows the data is a DB name. First, we create a folder with a database name. Inside that, we have a table name, and inside that, we have that data. And similarly, we also ingest the historical data using the ingestion framework that I have previously talked about in the same table folder, right? And from that, after that, so we use the framework. So we have a generic framework where we just create a YAML config file for that particular table, like what is the defining the paths and then OD related information like what will be the record key, partition field, and table name, and this information, and also like when the pipeline should run in an airflow. So all this kind of data, right? So what is the this in the backend? This information goes to the is used in the Airflow DAGs to create the DAG for that particular database table mapping. Right, there would be a DAG for that database table mapping, and when we run that DAG, so it triggers our framework where we pass all these things like the source path and the target path and the OD configurations and all of this. And in that we use the AWS Glue catalog and OD and Spark jars to first to create if a database doesn't exist, so first we have to create a database, and then using the Spark while writing Spark as a while writing the table using Spark and Hoodie, we can create that table and store the data in that. And if our database already exists, then we don't have to do anything. And in this, whatever the logic we have provided, right? So basically, on that runs and stores the data.
Okay. So you have used AWS Glue to run any Spark jobs in your entire pipeline
No,
anywhere?
no,
So how are you running are you run, you should be running some Spark jobs for some processing, right? After you might be
right.
storing, even for
So
ingestion, you
basically,
might be doing that, right? How are you running them?
yeah, so for that I have used EMR to run the Spark jobs, and like in the current framework that I was talking about, we use the Ocean for Spot where it provides the Spark apps which are running on the Kubernetes to run our Spark.
Okay. Okay. So you mentioned about airflow, right? So I think you would
Right.
be familiar with few concepts about it. So in general, right, it's a scheduler, and we kind of have different steps, and different steps might be handling different set of data at different points of the processing, right? So do you understand the concept of idempotency? Okay, I'll just maybe put it in some simple words. So let's say your Airflow DAG is processing some data daily, okay, and
Right.
due to some issues, the same day, I mean, same data might come multiple times to your step or to your pipeline, okay. So how do you handle duplicate data not coming into your end output? How do you handle that so that you're not messing up your end output data with that duplicate records or something that is not expected.
Right. So for that, since I was using, I use Hoodie to show the data in our table, right? So and let's say and mostly we use the absurd mode. So what it does is that we have a duplicate data that comes into the stream. So since we are let say we have column X which we have specified as a record key. So if it found there is another record with the same value in that X column. So it will then compare the precombined field, and since it is a duplicate record, so that precombined column will also have the same value. Then comes up to the hoodie, it can pick any of it can basically have finally have any of the one record, previous one or the current one, but there won't be any duplicate of duplicate.
Okay, so if I put it something in a different words in over here, let's say you have like in any scheduler, let's say Airflow, like you can have multiple steps or tasks, right? So let's say
Right.
a task is kind of dependent on multiple others, okay? And this particular task is having some issues because it has a dependency on some API, external API or anything, and you're facing some timeouts, okay? So, and you don't want to run already ran tasks. Like, let's say it is dependent on some 2 to 3 tasks to just retry this particular one, which is having the actual issue. You don't want to run the others that might be time taking or that might result in duplicate data, etc. Right? How do you handle this scenario? You understand the question, right?
Yeah, so like in Airflow, like we can like do the retry from that particular failed task
Mhm.
instead of running all the previous tasks which got succeed. We can basically run that fail, like we can clear that failed task, and Airflow will start from that particular task and onwards.
Okay, okay. So, okay, got it. So, let's say one more question I have here is like you have so your process is running daily, okay? And let's say you last 3 days back you got some data which is kind of bad or something. So they have like maybe the upstream or your data source has been updated and you have to process it again. So, how do you do that? Sorry?
Um, yeah. So like the
Basically,
problem
to
is
just
in.
to just put in simple words, like how do you handle a backfill of some data, basically?
Yeah, so basically what usually I do is let's say if it is our silver in this issue is in our silver layer, right? So what we can do is we can ingest first we can ingest the data from the source for let's say for those 3 days from the source to our bronze layer, and then we can run our pipeline for those only 3 days of data in order to correct those days of data in a table. And also before running the ingestion from our bronze to silver, we can delete the 3 days partition data using Spark to just delete those 3 days faulty data and then do the ingestion of those 3 days. Yeah.
Okay, so I have some question on Kafka. Okay, so let's say you have the Kafka, like in your data flow or the data pipeline, you have using like some streaming data and you have Kafka being used maybe as a producer or a consumer, whatever might be the case. So let's say like we should, so whenever we are handling the data, we should be taking care of the data quality, right? It shouldn't break the systems or we shouldn't be inserting some faulty data. So how do you handle those data quality? I mean, how do you make sure the quality of the data is meeting the criteria? And like in a streaming system, basically, in case if there is any issues, how do you gracefully handle those issues without affecting your actual pipeline?
So, in order to ensure that the schema of the data is correct, we can use the schema registry both at the producers and the consumer end. This is the one thing that we can do so that we can ensure that the schema of or the overall data is correct that we are expecting in our streaming job. There is
So, how do you like alert in such scenarios? Like, did you use any process in your experience to alert issues in the data pipelines, and how do you handle them?
So like in the on the streaming side, I haven't used the alerts on the jobs as of now, and on the like on the batch jobs, like here we what we have is we do have alerts on the airflow deck. Like let's say if one of my tasks fails, so we send those alerts to our Slack channel so that we can get to know, okay, there is this pipeline and this pipeline, this particular task got failed, and then we can check why it is failed, like what is the root cause of the failure.
Okay. Okay. Got it. So while we are discussing, like you mentioned about like during the if we have skewed data issue in Spark, right? We can use repartition. Can you explain me the actual concept of repartition, and also how does that differ or contradict with something called coalesce?
Yeah. So basically, repartition is used to basically let's partition the data in the number of partition. Let's say we specify, and we can also specify the column that we want our data to be partitioned on. And basically, the difference between the college and repartition is like in the college we can only decrease the number of partitions. Let's say if my current data frame has 100 partitions, so we cannot increase it to 200 using call list. We can just reduce the number of partitions. Call list is generally fast than the repartition, and the other thing is, if I am not wrong, repartition divides the data uniquely in each partition as there is shuffling of data take place, but whereas in call list, it can repartition the data in ununiquely as well. Like there's no shuffle in the call list.
What is
Shuffling is basically when we use a wide operation where like data goes from one partition to another. Like for example, if we are let's say joining two data frames, so there what will happen is like on the basis of some key. So first on that key, the in the partitions, so like there will be a data shuffling, like it will map the data on the basis of that key and match it with the other data frame, and then it will join the rows.
uh, how can we minimize?
Can
Maybe
minimize
take the
the shuffling.
scenario of joins only you're mentioning, and in such scenarios, like just take an example maybe of maybe two data sets
Oh,
and
right.
explain me any scenario you can consider to wherein you do certain things to reduce shuffling. Let's say one
Right.
data set is small and the other data set is large, okay, and I want to join them.
Yeah.
So
So
is there
in
any way I can minimize shuffling?
yes, so basically in such case what we can do is we can use broadcast join, and we can broadcast the smaller data set to each worker node, and then by using this we can reduce the shuffling.
Okay, cool. So, while in your work, like, what are the different file formats you have used?
I mainly work with Parquet file format.
Mostly Parquet.
Yes.
Okay. What are the others you have an idea of?
There is an ORC file system.
Any difference between these, and any particular advantage of choosing Parquet in any particular scenario you can talk about?
Difference. So the difference I can do like one is like the process that I don't remember right now, but one of the advantage of Parquet is of the predicate pushed down. So let's say if we are doing any filter operation, so in Parquet file format, what happens is those filters got passed to the files, and only those which qualifies that filter, like which column, so it reads only that amount of data instead of reading all the file data.
Okay, anything else? Like, what is your scenario of choosing parquet?
Yeah, so basically we were using that only for.
Okay, okay. As like we are talking about, I think S3 hoodie and everything, right? So, do you understand the concept of data lake?
Yes.
Okay, and
Uh,
can you talk to me about that and how it differs from a normal database or a data warehouse?
Yeah, so basically in data lake, we can have data in like any format, and that is like we can have a raw data in our data lake, whereas in our data warehouse or database, we have the process data that is also present in the form of tables and the difference is that, and then we can have uh, um, with like in data lake we can have very um, huge historical data, maybe like of 10, 20, 30 years of data is stored in our data lake, whereas in data warehouse or database we have much recent data compared to data lake because of the storage and other. The other is like on the data warehouses or databases, we can write simple queries to read the data and extract information from it. Whereas in case of data lake, we have to read the file, all the files, and then we have to write a lorry to extract data from.
So you worked with hoodie, right? So do you understand the concept of data lakehouse? You heard of it?
Uh,
Do you know about it or like yeah, just want to know?
Little bit.
Okay. Can you talk to me about that? Like, what do you have an idea of?
So basically, like data lakehouses, we can say we can maybe have data from various sources, storing in the form of files in some storage location.
Okay. No problem. Okay. So I just have like let's jump into some coding and then maybe some SQL. Can you share your screen? Maybe a notepad. We'll try
Uh,
out one simple Python question.
yeah,
Can you just take a list of numbers, okay, that contains 10? Can you write down the
okay,
numbers? Yeah,
yeah,
just write down the list of numbers, okay.
okay. So,
10, 25,
hmm,
35, 15,
15, okay,
40,
40, okay.
okay. Yeah. Uh, can you give me a pair of two numbers whose sum is 50?
Okay, there, 50, okay.
50, yeah. You can
Yeah.
first discuss
Uh,
the logic with me and then you can then just write some pseudocode.
Right. So what I can do is I can make a dictionary of this numbers. So that in my dictionary I have all this numbers, so 10, 25, 35, 15, and 40. Uh, And then let's say if I say like if 10 is my one number, so I will find if 40 is there in that dictionary. So if it is present, then my pair is 10, 40. Else I will look for 25, then another 25 should be present in right. And similarly, we can go on to 35, and then 15 should be present to find the sum, like to find the pair which sum is 50.
Okay, can you just write a pseudocode of it?
So let's say if I decrease this and looking into the same numbers. So, like I have to return the pair or
Yes, return.
okay. So maybe we can create a list of uh, this is this and Uh, um, uh, uh,
Uh, Maybe can you just walk me through the code by taking
yeah,
our input list?
right. So basically, this follow will be iterating over this list. So every time when I enter into the loop, I like for the current index, I stored it in my current sum. So let's say my current sum becomes 10 for first, and then it will check 50 minus 10 is there in the dictionary case, but my dictionary is empty for now. So it will go to here and store and map it to index which is 0. Right? Then it goes to
Mhm.
25 and it will again check like if my current sum now will become 25 and now 50 minus 25 is 25. So it will check if 25 is present in the dictionary, which is not like my dictionary will now have just 10. So it will come it here and append 25 and 1. Now it will come again 35. So now my current sum will become 35 and it will check 15 is 35, which is 15 is there in the dictionary or not, which is not. So it will add 35 and 2. Now the 15 comes and now 15 minus 15 is 35 and 35 is there and 35 is stored at index 2 and my 15 is at 3. So these are not same. So it will add the 35 at 15 into my answer list and will return that answer.
Okay, what would be the complexity of this?
It will be often.
Okay, so yeah, can you open the document I just shared with you with the
Yeah,
SQL
yeah.
thing? Yeah. So I'll just walk you through the scenario over here. So just assume that you're working for some space agency and you want to like go through their data and give some insights uh, of their need basically. Okay. So we have a different set of tables over here. The first one is the astronauts table, basically the persons like who had gone through some missions. And then second table, if you scroll down, there is different missions that kind of happened at different start and end times, like the duration basically in space. And then the third table, if you scroll down, it's like in which mission, who are the people that are part of it. And the fourth one is basically it's just the space stations that we have that are launched. And then the last table is the visits, basically which astronaut or which machine has went into which station, basically. Okay.
Which mission? Okay.
Okay. So my first question, if you just scroll down a little bit down, is you just have to find the list of all the people who have participated in more than one space exploration, basically.
Okay,
Okay.
so and that like what like I have to print the names or what?
Yes, yes, you can print the name or ID. Anything should work.
Okay, if I have to just print the ID.
Maybe you can just go through the tables and let me know what all the tables you have to consume over here and how do you want to take it. And then we can jump into writing some queries.
So basically, if I have to just return the astronaut ID, we just need this mission view table. And in that, what we can do is we can select the astronaut ID and group by it, which have the count greater than like we have to return in more than one mission. No? So greater than one.
Mhm.
So it will give us all the astronaut IDs who have gone for more than one mission. And if we also need the name, then we can just join this returned astronaut ID with the astronauts table and get the name of the astronauts.
Okay, can you write the SQL query for that, for the first question? Just simply take it as ID, name, and mission ID, mission name kind of.
Okay.
Just take the first table as astronauts, and the next is the missions. I mean, mission visit.
This will return the astronaut ID and the name.
Here, when you say group by one in the second query, what is that?
So group by one, it will take the astronaut ID, like the first column in the
Mhm,
left close.
mhm. Okay,
Uh,
okay, fine. So yeah, we can go to the second question. Okay, scroll down. So my second question is I mean, find the top three countries who have spent most of the time in space. Basically, if you can you go scroll to the tables, I'll just explain you to the start. Yeah, yeah. So if you see here in the table two, so I want you to find the countries. So we have the countries from the table one, and the countries which have spent whose astronauts have spent most of the time in space. Basically, you have to find the duration of the missions. Like, let's say an exploration took, you have the start and end time of an exploration, right? And you will get
right.
kind of duration of each exploration. So, and each exploration have different astronauts from different countries, right? Based on that, you can find from for each country what is the span of the exploration. And I want you to find the top three countries who have spent most of the time in space, basically. Whose astronauts you can
Uh,
see. You get my question?
okay. So, just one thing, like,
Uh-huh.
since, like, let's take the first, like, astronaut
Mhm.
one, that he
Okay.
was part in two missions, 101 and 102 mission ID, right? So
Mhm.
now one belongs to USA. So USA, like the total duration will be the sum of the difference of days in start and
Yeah.
end of both
Mm,
the two
mm,
missions.
mm, mm.
Okay, it will be the sum.
It Yes, yes.
If we join this mission ID with this table, so we'll get the astronaut IDs, and if we join this astronaut IDs with this table, we'll get the nationality mapped
Okay.
to each mission.
Okay.
And then what we can do is we can first calculate the number of days using date diff between end
Mhm.
and start date,
Okay.
right? And then on the basis of nationality, first we have to calculate the sum of that difference to find the number of days that each nation astronaut was in space. And after that, we can use a row number function to just find to in order to find the top three nations.
Okay, okay, I get it. I think, yeah, I think we are good. Maybe I have one more question on the same set of data over here. I understood your
Okay.
solution for question two. That should be fine. We can skip the query for now. So for the question three, right? Let's take a part of it for now. Okay. So I
Okay.
want you to rank the explorers, basically the astronauts, based on their time spent in space, basically. Something similar to question two, but I want you to rank them across all their explorations.
Yeah,
Okay.
so basically, again, just as I had previously done. So again, what I'll do is I'll join the mission table with the mission view table, right?
Mhm.
So since like mission view would be on the left hand side and it would be a left join, so each of this data will get mapped to this each row. then like we have in each other, and then we can just again find the difference of this start and end date, and then do a total sum on the basis of the astronaut IDs. So now we'll find like each astronaut has spent how many days in the space across all the missions, and then we can again use the row number to just rank them. And if we require more information, we can just join that data with this astronaut able to get their names and the information.
Okay, got it. Yeah, I think we are good. Thanks for attending this.
Yeah. Thank